Hello, Dr. Ali. Today I will explain my heart problem. So let's begin. We need to find an area bounded by this function, which is my main function. So in order to find area, we just first we need to use polar generalized polar coordinates. So as you can see, I already right here, so which is x equals to r square multiply cosine power of 4 alpha, and y is equals to uh, b multiply r square multiply sinus power of 4 alpha. So so in order to our first step is going to be use Jacobian formula, which is already given here. We need to find matrix of partial derivatives of our polar coordinates in respect of uh, r and alpha. So I already find partial derivatives. They are all here. So we just need to put them and find the matrix. In order to find matrix, we need to multiply diagonals and subtract them finally. So after we put everything, we are going to find 8 multiply a multiply b multiply r cube multiply cosine cube alpha multiply sinus cube alpha. So we understood this part. So our second part is going to be we just need to put x and y into the main function in order to find our r. So as you can see, I already put here, so I don't want to tell again. So after we will find r is equals to this function. uh, that's all, and we don't forget that we our r is going to be between 0 and this function. But and also our like in order to find area, we need to find the first integral, which is uh, from 0 to what. But that's why p over 2 is coming from this function, because the interval of our alpha is here is between 0 and p over 2. So we will use, as I said, we will use double integral. First integral is going to be from 0 to p over 2, and our second integral is going to be from 0 sorry, from 0 to this function. So we just need to find the integral of 1 multiply our Jacobian. So yes, we will just in first part we will find our first integral, which is in respect of r. We will get this function. So we will put everything, and we eventually we will get this equation here, which is equals to, as you can see, I don't want to say that I wrote here that from 0 to p over 2. I'm just summing them here. I didn't find them in the exact integral. I grouped them in. I grouped them separately. So we just need. I found first this part, then second this part. So I will explain the first part, because the second part is the same method I used in first part. So that's why if I can explain this part easily, so we don't need to explain the second part also. So let's start first integral here. So as we know that we need to find this integral in respect of alpha, so we don't need this to multiply a cube b over h square. So we will see them as a constant. That's why we will write like that. But don't forget that before we start substitute, we need to know that sinus square alpha equals to 1 minus cosine square alpha. So we will simplify our function, which is going to look like that. So we will use substitution method here, which we will use u as a cosine alpha, and we will find the derivative of u in respect of alpha, which is going to be minus sinus alpha. But we need to take from here is d alpha, which is going to be minus du over sinus x. So our function is going to be look like that, which is equals to u power of 11 multiply u square minus 1 in respect of du. So it's easier to find the integral of this function, which is going to be u over 14, u power of 14 over 14 minus u power of 12 sorry, power of 12 over 12. Then we just need to unsubstitute our function, which we will put cosine alpha into u, so we will get this function here. So as you remember, we had a constant here, so we just need to multiply them. But before we multiply them, we need to find the sum of from 0 to p over 2. So we will just put p over 2 to the function and 0 and subtract them. So we will get 1 over 12 minus 1 over 14. We will multiply them with the constant we wrote here before. So we will get h cubed b over 42h square. Also, the second part, which we will find integral of this function, it's going to be the same method. As you can see, I don't want to explain it again because it's the same method, it's the same thing. So we will get eventually here ab cube over 42 k square. So yes, after we found these two integral, as we know that there's a plus icon here, so we just need to sum them, some of them. So we will get so as you can see, we are going to sum them and add. We will get finally ab over 42 multiply a square over h square plus b square over k square. So this is going to be our final answer. Thanks for listening. Have a good day.